Hi guys, welcome to lesson 29.3, finding horizontal and vertical asymptotes. We're going to be talking about some key features that we didn't get to in class on Friday. So you will need your lesson 29.3 note sheet that is posted in Google Classroom with this Edpuzzle, and you'll want a pen or a pencil. And here's what we're going to do. We are going to identify horizontal asymptotes of rational functions, identify vertical asymptotes and holes of rational functions, which we did in class, and then identify intercepts, of rational functions. So here we go. First thing, we did not talk about horizontal asymptotes. So those are going to run left and right. Remember, an asymptote is like that invisible line that your graph will approach or get closer and closer to, but never actually touch or cross, okay? So a horizontal asymptote depends on the degrees, the largest exponent, okay? So remember, if we have something like x squared minus 4, that is a second degree polynomial, okay? That's something we talked about back in Unit 2 or Unit 3, okay? So what you're going to do is look at the degree of the numerator and the degree of the denominator, and that's going to describe the end behavior of the rational function. So to identify the horizontal asymptote, we want to leave the rational function in unfactored form, okay? So before we do any factoring, we need to determine this. So there are 3 cases, and you're going to want to either write this down or have these memorized, okay? If the degree of the numerator is equal to the degree of the denominator, so if it's like an x squared over an x squared, then you're going to find the ratio of the leading coefficients represented by y equals that number, okay? If the degree of the numerator is less than the degree of the denominator, it's going to be y equals 0. The horizontal asymptote is always y equals 0 then. Okay, if the degree of the numerator is greater than the degree of the denominator, so if it's bigger on top than on bottom, then there's no horizontal asymptote, so you would say none. So let's take a look at these first. So example A, you have 2 minus x. So first thing, be careful, get it into this standard form. So let's rewrite that as negative x plus 2 over x plus 4. Okay, so now we have it in both in standard form, so we can look at the degree or the largest exponent. So the degree here, technically, remember, if there's nothing, it's a 1. So we've got a degree 1 in the numerator. And then again, same thing, if there's nothing, we can assume it's a 1. So this is a degree 1 over degree 1. So if they are equal to each other, you're going to find the ratio of the leading coefficients. So our leading coefficients are what's out front. And so it's technically like a negative 1 over 1. Remember, you can say 1 and 1 out front. So negative 1 over 1 is going to tell us that y equals negative 1. Okay? So that would be your horizontal asymptote for the first one. For part B, let's again look at the degrees. So we have a 2 on top here on the numerator. And then we have a 1 in the denominator. So because it is larger in the numerator, the degree of the numerator is larger than the degree of the denominator, we are going to say none here. There is no horizontal asymptote. Okay. And then this last one, okay, we have x to the first power over x squared. So the degree of the numerator is less than the degree of the denominator. So that's going to mean that your horizontal asymptote is always y equals 0. And that's it. So those are the 3 different cases, but you do have to remember those 3 or have it written down to help you. Okay? So if they're equal, you find the ratio of the leading coefficients. If it's greater in the denominator, then it's always y equals 0. If it's greater in the numerator, then it's none. Okay? So that's how you find a horizontal asymptote. And again, you want to do that before you do any factoring. All right. Then vertical asymptotes and holes. We talked about this in class. So I'm just going to do one really quickly. But remember, what you want to do is factor the numerator and denominator. So I'm going to take out, I'm going to do part B here. So the numerator is already factored. So I'm going to leave that the same. And then the denominator, x squared minus 9. So I'm going to rewrite that. It's a difference of two squares. I'm factoring that to be x plus 3, x minus 3. Okay. Remember, whatever cancels on top and bottom, that becomes your whole. So we would cross these out, set it equal to 0. So you have a whole at, and if we added that 3 over, we would know it's at x equals positive 3. Okay, so that's part of your answer. But then it's also asking for the vertical asymptote, which is anything left over in the denominator. So we would set that x plus 3 equal to 0. So we would have a vertical asymptote, VA, at, and that I would just subtract over the 3. So we would say at x equals negative 3. Okay, so go ahead. I want you guys to try that last one, part C. And you can see some of my factoring there, but I will go ahead and show this in a second. But I want you guys to pause the video here and try part C. Okay, so hopefully you paused and you tried this one out. So you should have factored the numerator and the denominator. On top, you should have been left with x plus 7 and x minus 2. On the bottom, a difference of two squares, you should have been left with x plus 2, x minus 2. Okay, the x minus 2's cancel, so you are left with a whole at x equals positive 2. And then the x plus 2 that's left over in the denominator, set that equal to 0, and you're left with a vertical asymptote at x equals negative 2. And that's it, okay? And we did some of those in class. All right, so now we know our horizontal asymptotes, our vertical asymptotes, and our wholes. Next up, we need to talk about how to find your x and y intercepts, okay? So points where the function crosses the x and y axes, that's what your intercepts are. To identify these, we want to use the factored rational function. And to find your x-intercept, you're going to set the numerator equal to 0 after crossing anything out. So that's what I talked about in class, how we weren't really doing much with the numerator, so now we are. And then your y-intercept, you're going to plug in 0 for all of the x's and simplify. Okay, so let's go ahead and try this first one. Again, we want it in that factored form. So I'm going to go ahead and factor the numerator, should be x plus 3, x minus 3, because it's a difference of two squares. The denominator, you've got negative 15 and 2, so that's going to be 5 and negative 3. So let's write that as x plus 5, x minus 3. Again, we would cancel these. Whoops. That would be where your whole is at 3. And so what we have to do is just set the numerator equal to 0. So here's your numerator. X plus 3 equals 0. Subtract the 3 over, so you get x equals negative 3. And then because it's your x-intercept, you want to write it as the number, negative 3, as your x value, and then 0. So you want to write it as an ordered pair. So that would be your x-intercept. Oops. Okay. Then, as I mentioned, to find your y-intercept, you are going to plug in 0 for all of the x's and simplify. So you can do that actually to the original or the factored. Because the factored is already kind of simplified, I'm going to do that. So I'm going to plug in 0 for this x and 0 for this x. So that would be 0 plus 3 over 0 plus 5. Well, 0 plus 3 is 3, and 0 plus 5 is 5. So that means that our y-intercept is at 3/5, but again, we want to write it as an ordered pair and plug that in for the y value. So we would say it is at 0, 3/5. And that would be your final answer. Okay, so again, one more time, to find your x-intercept, take what's left in your numerator and set it equal to 0. To find your y-intercept, plug in 0 for all of your x's. Okay, so I want you guys to go ahead and try the next one, part B. So first do your factoring and cancel. Then what's left in the numerator, set it equal to 0, that's your x-intercept. And then plug in 0 for everything, that's your y-intercept. So pause the video here and try that. Okay, and this is what you should have gotten. So again, if I were to have factored this, it would look like x minus 1 over x plus 1, x minus 1. So those would cancel, and you're left with just 1 over x plus 1. So if you set your numerator, you're going to get 1. And then if you plug in 0, you're going to get 1. So the x-intercept is at 1, 0. The y-intercept is at 0, 1. All right. Awesome job there. And the last thing we're going to do is just put it all together. So now we have your horizontal asymptotes, your vertical asymptotes, your holes, your x-intercepts, your y-intercepts. Okay? So the first thing, that's why it's listed first, that I'm going to come up with is the horizontal asymptote, because you want to find that when it's in its unfactored form. Okay? So I'm looking at the degree on top and the degree on the bottom. Both of them are 2. So remember, when it's the same degree, you are looking at those leading coefficients and making a ratio. Well, they're both 1, so 1 over 1 is just going to be 1. So we have a horizontal asymptote at y equals 1. Okay, that is your first step. Then we're going to factor. So now, once it's in factored form, so we had x squared minus 4. That's going to simplify to x plus 2, x minus 2. It's a difference of 2 squares. On the bottom, we're going to put negative 10, negative 3. What multiplies to negative 10 that adds to negative 3? Negative 5 and 2. So we're going to put x minus 5 and x plus 2. Let's go ahead and cancel, whoops, not that, these x plus 2's. So I'm going to set x plus 2 equal to 0. And so x equals negative 2 is my whole. That was the next step I wanted to do. Perfect. So x equals negative 2 is my whole. Then the next step is the vertical asymptote. Excuse me. So I'm going to set this x minus 5 equal to 0. What's left in your denominator? And I'm going to get that that is at x equals 5 when I add that over. Okay. Next, I'm going to find my x-intercept by setting what is left in the numerator equal to 0. So that's going to be at x equals 2. But remember, these we want to write as an ordered pair. So let me write that here, 2, 0. And then last up, you can plug in 0 for all of your x values. Or if you wanted to, you can just do it. So our most simplified version is that x minus 2 that's left in the numerator. Whoops. Over that x minus 5 that's left in the denominator. And so if I just plug in 0 here and here, it's going to be 0 minus 2 over 0 minus 5, which is going to be negative 2 over negative 5, which is going to be 2 over 5. So that would be 0, 2/5 is where your y-intercept is going to fall. Okay. So it's a lot of work to do all 5 pieces, but they're each easy steps. You've just got to follow through and remember what each one does. Okay. Horizontal asymptote, you're looking at the degree of the numerator and the denominator. Holes are what cancel out. Vertical asymptote is denominator. X-intercept is numerator, both of those, what's left. And then y-intercept, plug in 0 for x to get your y-intercept. Okay. All right, so the very last thing here is I want you guys to try your own. So you are trying part B here. You have x squared plus 2x in the numerator and x squared minus x minus 6 in the denominator. Okay, so pause the video and try to come up with all 5 key features here. All right, so hopefully you paused and you came up with this here. So again, your horizontal asymptote, they had the same degree. So we made a ratio of 1/1, so y equals 1. Your wholes, what canceled here was the x plus 2, so you have a whole at x equals -2. What's left in the denominator is x minus 3, so x equals 3 is your vertical asymptote. Your x-intercept is what's left in the numerator, and that's just x, so set that equals to 0, x equals 0. So again, whoops, we're going to write that as 0, 0. And then your y-intercept, you plug in 0 for the x values, so that would just be 0 over 0 minus 3. Or I plugged it into the original here in orange. But either way, you're going to get 0. So again, that ordered pair would be 0, 0. Okay. And that is it for your key features. So if you have any questions, you can leave them here. Otherwise, we're going to be going over this in class the next couple of days. Okay. Have a good one. Bye-bye.